Hello everyone, I'm Paul and today we're solving problem 1518, water bottles. This is an easy one, so this will be quick. We are given some number of water bottles and some exchange number, which represents the empty water bottles that we need to get one full water bottle. And we need to return the maximum number of water bottles that we can drink. So let's go with this example. If we are given 15 water bottles and num exchange is 4, first we can drink these 15 water bottles, so the result is 15 right now. And now we have 15 empty water bottles. And the question is, how many new water bottles can we get from 15 empty water bottles? So we do 15 divided by num exchange, and we round down this value. The result is 3. So we add this to the result. And how many empty water bottles do we have right now? Well, we have the 3 water bottles that we have just consumed, meaning these 3, plus the remaining water bottles, remaining empty water bottles. How can we get this value? Well, we do 15 modulo 4, and the result for this is 6. So now we have 6 empty water bottles, and we repeat the process. We do this divided by 4, and this is 1, so we add 1 to the result. Now how many empty water bottles do we have? Well, we have 1 plus 6 modulo 4, which is 2. So we have 3 empty water bottles, and given that we don't have enough empty water bottles to get a new full water bottle, we return the result, which is 15 plus 3 plus 1, meaning 19. So with this in mind, let's go with the code. First, we can say the result is num bottles. We are drinking this right away, and while num bottles is greater or equal to num exchange, the amount of bottles that we can drink is num bottles divided by exchange, and we add to the result drink. And now we need to update num bottles. This is drink plus num bottles modulo num exchange. Here we end the simulation and we return result. So now let's submit this and see if it works. As you can see, this works and it's very efficient. Here time complexity will be given by num bottles divided by num exchange, and in the worst case this can be 2. So this time complexity will be roughly big O of num bottles, and space complexity big O of 1. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.